Hey folks, my name is Thórisson, and I wanted to share with you some thoughts that my collaborators and I have put down about the historical and present relationship between AGI, AI, and CogSci. So these fields, if you separate the issue of understanding what a mind is in this way, were essentially initiated by the same insight that that machines are an interesting tool to study minds with, and perhaps they're one and the same. CogSci has traditionally focused on the scientific aspects, natural science perspective, looking at cognition in the wild, and AI, the engineering aspect, how to build such machines. So we should be able to live happily as the same family, right? Well, it didn't quite work out that way in some ways, because it turns out this is a very difficult task. So a couple of things have happened. Basically, CogSci and AI didn't have the happy marriage that at least I kind of expected in my early days of studying. But even further, both AI and CogSci, in our opinion, have diverged from their original seed, so to speak, and essentially downgraded their agenda. Mainstream AI basically slicing up the problem of thought into very small pieces that, although many think they can put together again at some point in the future, at least some people here in this crowd think it's a foregone conclusion that it's not going to work that well, or at all. And mainstream CogSci has actually stopped focusing on, as the field says on their webpage, they focus exclusively on human cognition rather than the original idea, which was to study cognition in the wild in general. So, in some sense, AGI is a way to return to the origin, the emphasis on the G. That's how the G ended up between the A and the I. Of course, AGI inherits naturally, or should be able to inherit some results from CogSci on how the human mind works, and results from AI on how to use computers to study this phenomenon. But we should look to these fields, but we should avoid repeating their mistakes. What's wrong with AI and CogSci today? Well, in AI, there's an overemphasis on computationalism, in the sense that everything has to be analyzed as an algorithm, and there's an obsession with algorithms and the Turing machine. And in CogSci, there's an overemphasis on anthropocentrism. So this is not really very fruitful for getting to AGI, in our opinion, and essentially justifies, in my opinion, the fact that we are here for these few days. The computational framework that can be traced back to Marr and even further back, but this is basically very strongly comes strongly out of the computer science tradition, and cognition is specified as a function that maps inputs to desired outputs, and therefore cognition must be an algorithm, and then you implement an algorithm in a computer system. But there's actually two senses of computation that gets confused a lot. Computation is whatever a computer can do, or computation is a process defined by an algorithm. And these are not two identical senses of the term computation. In fact, our conclusion is that theories of computability and computational complexity that is inherited from, that we could be looking to from computer science, are not really applicable in the second sense, because what we are dealing with there is at a higher level. And I'll come back to that in a bit. So, if we assume that an unrepeatable process, such as, for instance, our mental histories, can still be formed from repeatable steps, it's perfectly fine for AGI to be designed as a society of algorithms or interacting algorithms. But at the problem-solving level, you can't use computability and computational complexity theory. So theoretical computer science really is kind of out of the ballgame. And what we think is important here that gets left out of the equation includes history or adaptivity and context or flexibility. So let's take a quick example here. If we treat learning holistically as a ubiquitous, anytime, process-sensitive, open-ended, and lifelong process, we're much closer to the way that we see learning in nature than what, for instance, machine learning is doing today, which is slicing all of these up into separate parts, bits, that then are based on different fundamental assumptions, which don't allow you to put them all together. So in other words, you can't, in our opinion, go towards AGI if you do it that way. And so I think that here there's a really important focus that is left out from at least current AI and CogSci, but that was strongly part of the cybernetics tradition, which is systems. On the other side, though human cognition and intelligence is undeniably our best known example and what we strive to, that's why we always say human level, as a way of measuring our ambition here. It's not obviously the only possible form, but we should ask the question: how much do we have to mimic human cognition? And that's relevant, for instance, to the question of should we hang everything on language, or should language be a necessary benchmark? Should human preschool or human college be part of a general AGI measurement toolkit? So, what we should do in AGI, in terms of CogSci, is think about or look towards the beginning of that field and think about the functional viewpoint, like intelligence in nature. There are some functions that obviously are shared between human intelligence and chimp intelligence, or even parrots, and we cannot become so human-centric as to ignore these similarities. Not any more than we should ignore language altogether. So I guess I can wrap this up by saying, the take-home message is human intelligence and computer intelligence are probably special cases of intelligence in general. We should pay attention to their similarities and differences, and we should clearly set our objective in AGI as wanting to implement general intelligence principles in computers without overemphasis on the computationalist viewpoint, the toolkit that we can inherit from computer science, or the human or anthropomorphic centric view that CogSci science has sort of brought itself to today. So that's it. Thank you.